those listening. Does $1 times $1 equal $1, or does $1 times $1 equal $2? I have never seen anywhere in the universe where an action times an action doesn't have a reaction. So now that's why we need to discuss this and examine it and how they came up with this strange number which is illogical, because a length times a length has to have an area. So you can't have a 1 times 1 equaling 1, because now what happened to the length times the length? The area is no longer in existence.
Terrence starts by posing an intriguing question. Money can't be multiplied, or can it? A penny times a penny equals what? Since the penny is no longer based upon the hard asset of gold and is now based upon an imaginary value that is equal to a virtual value of the integers or numbers, then it follows 1 penny times 1 penny equals 1 penny, according to the rules of current mathematics and multiplication. 1 penny times 1 penny equals 2 pennies, according to the laws of universal mathematics. 1 penny times 1 penny equals 0.0001. According to a calculator, a penny times a penny, 0.01 times 0.01 equals 0.001. Does a penny times a penny equal 1 penny based upon the rules of multiplication? Or does a penny times a penny equal 0.0001 based upon our current decimal system? A value so small that there isn't even a currency circulated for that amount by the US Department of Treasury. All calculations shown here are reasonable forms of multiplication, but which one remains consistent with observed universal phenomena? How would you like your money calculated? A nickel times a nickel equals what? A nickel is equivalent to 5 pennies. Then a nickel times a nickel should also equal a quarter. A nickel times a nickel, according to the calculator, is 0.05 times 0.05 equals 0.0025. Again, a value so small that there is not a currency circulated to represent it. How would you like your money calculated? A dime times a dime equals what? A dime is equivalent to 10 pennies. A dime times a dime should be equivalent to 10 pennies times 10 pennies. 10 pennies times 10 pennies is equivalent to 100 pennies, which is equal to $1. But a dime times a dime equals a penny according to a calculator. 0.10 times 0.10 equals 0.01. How would you like your money calculated? What is a quarter times a quarter? A quarter is equal to 25 pennies. Therefore, a quarter times a quarter equals 25 pennies times 25 pennies, which equals 625 pennies, which is 6.25 US dollars. Yet a quarter times a quarter, according to the calculator, is 0.0625. 0.25 times 0.25 equals 0.0625. How would you like your money calculated?
Allow me to enlighten you. If 4 over 2 is the inverse operation of 2 times 2 equaling 4, then it would naturally follow that 2 divided by 1, or 2 over 1, is the inverse operation of 1 times 1 equaling 2. So let's talk about this. What does your common sense tell you about these two scenarios? What do they have in common, and what are their differences? Division. The number 4 is divided by 2 twice. And the truth is, the number 2 is divided by 1 twice. The proof of that, if you had $2 and split it between 2 people, you would have to give each person $1 in order for it to be even. In addition, 2 plus 2 equals 4, and 1 plus 1 equals 2. Subtraction, 4 minus 2 equals 2, and 2 minus 1 equals 1. Multiplication, 2 times 2 equals 4, and 1 times 1 equals 1. Does that make sense to anybody there? Does that seem like it's following any similar line of congruency? I mean, can you see where the mistake has occurred? Both of these scenarios are identical in every way. The only difference exists in dimension alone. If they add, subtract, and divide according to the same ratio, then they must also multiply according to the same ratio, plain and simple. If 2 over 1 is inconsistent with 1 times 1 equaling 1, although 4 over 2 is consistent with 2 times 2 equaling 4, then it should follow that 2 squared equals 4, which it does, and 1 squared equals 2. Yet the math and scientific community tells us that common sense and logic are wrong in this case because of a product of an arbitrary convention called the identity property. Let's discuss.